Hello, everyone. Welcome to our lecture on the Archaeology of People, Human Remains and Archaeological Investigation. First off, I think it's important to talk about what are the kinds of things that we can learn from human remains. And we'll be covering examples from a number of these today in the lecture. Biological sex is one of the things that you can learn. You can tell whether a skeleton or other portions of human remains are from men or women. You can look at issues of longevity. How long do people live? What's the average age of death? What is the nature of aging in different ancient societies? Obviously, looking at things like physical appearance, both from mummified remains in the case of Tolland men from Denmark, shown here, as well as facial reconstructions, which we'll talk about in a little bit. You can look at relatedness, the constructions of genetic relatedness or familial relations within societies. Who's moving? Does the wife move to live with the husband's family or vice versa? All of these things are amenable to examination through bioarchaeological techniques. You can also look at issues of migration, populations moving from one area to another, populations migrating from one community to another, and we'll show some examples of that as well. You can also look at pathologies, disease and injury, sort of the forensics of the past, if you will, as well as issues of longer term trauma, if you will, to the human body related to things like diet and or malnutrition. So first off, on that list, the modern human pelvis. You can see shown here a number of the different portions of that. The whole thing is referred to as the os coxa. The sacrum is the portion of that conjoining of skeletal elements that actually attaches to your lower vertebral column, your lower spine. The ilium is the part that you can feel on the side of your body. And this is where your femurs attach into the acetabulum. You can look at these and understand that there's a number of different anatomical features that vary not just between individuals in an idiosyncratic way, but in patterned ways that allow us to understand quite a bit about the individuals represented. Some of the features of the pelvis that are useful in determining the sex of the individual include dimensions of the ventral arc along the pubic symphysis. You also have a subpubic concavity on the underside of that bone, as well as an ischiopubic ramus, that part of the bone that sticks up from the ischium and moves toward in the direction of that pubic symphysis at the midline in the anterior or front portion of the pubis. And there's features there that are distinctive as well. And perhaps most notably, you have the sciatic notch. You can see in the bottom left illustration there a score of 1 through 5 of the angle of that sciatic notch, with a very robust male pelvis exhibiting the trait of the sciatic notch more towards the right end of that spectrum, and female pelvises towards the left end. So it's a more acute notch in males than in females is the general pattern. And when you combine a number of different traits in here, then you're able to be even more certain that your determination of sex of the individual has merit. And you can see here side by side a male exemplar and a female, and you can see particularly in that sciatic notch there to the left of the acetabulum, the left of the socket there for the femur, That's the sciatic notch, and you can see the one on the left has a much more acute angle, and the one on the right, the female pelvis, is much more open in that sciatic notch there. And if you're interested in looking more in depth at this, there's a link that's also been posted to the Canvas site, but I would recommend taking a look at that. You can get a lot more details from the American Association of Forensic Science. Talked about being able to determine age of the individual. Some age determinations can be based upon epiphyseal fusion, tooth eruption, cranial suture closure. We'll look at some examples there. Here you can see the age at which the epiphyses, or the ends of the bones, fuse to the long shaft. You can see some of these, for example, of the feet and ankles begin to fuse when you're 15, 16 years of age. Others in your late teens. And your shoulder, the upper portion of your humerus, the proximal humerus, doesn't fuse to the main shaft completely until around the age of 20. So these are very good markers for distinguishing age of individuals up through late adolescence. With even younger individuals, you can see similar kinds of patterns of fusion of different components of these. The tubercles and trochleas and the epicondyles of your distal humerus are also very useful for distinguishing age of juvenile individuals that are not yet in their teens. For older individuals, you can look at the sutures in the cranium. The skull actually is not a single bone, but is made up of several major components as well as a number of minor ones. You can see the frontal bone there at the top. That's your forehead and the front part of the crown of your skull. And then you've got the parietals on the sides, those two roughly symmetrical pieces on the side, and then the occipital there in the back part of the skull. Those are just the ones visible, the sutures visible from the top view of the skull that you can see here. And what's interesting about these is that the age at which these sutures between these different bones actually begin to fuse and create a completely single bone element vary in terms of from the late 20s there, where the rear portion of the parietals begin to fuse to one another, all the way up through your early 40s, when these different portions begin to meld and fuse together. And so this gives you a good indication, a good way of distinguishing between individuals post-adolescence, fully adult individuals, but who have not yet entered into sort of old age, sort of fully adult to middle-aged individuals. These cranial sutures can be very useful in making those kinds of determinations. For obviously even younger individuals, in terms of infants and children, you can look at the age of tooth eruption, all the way up through, again, adolescence, for age of months when you're talking about the baby teeth, and then as the permanent teeth replace those, you can get even better estimations of age there. And so what's interesting, if you think about being able to get more precise determinations or estimates of the age of an individual, it's often much easier from a forensic bioarchaeological standpoint to get a narrow range for individuals that are either infants up through about age 20. After that, after age 20, it becomes a bit more difficult because there aren't these clear markers that are fixed to certain time periods of maturation and development. And until you begin to see some of those other markers with regard to cranial suture closures in the late 30s and 40s, when you're able to get some of those estimates. And then beyond that, beyond the 40s into the 50s and 60s, it can become also a little bit fuzzier. So that's sometimes why when you see people making age estimations with skeletal populations, sometimes it will be relatively tight. Oh, this is a 10 to 12-year-old child. And other times they'll say this is an adult in their 50s. Because distinguishing between somebody who's 52 and 57 just based upon their skeletal material can be very difficult. Meanwhile, distinguishing between somebody who's 5 years old and somebody who's 10 years old is actually a lot easier to do based upon these calculations and measurements. Another thing that is really fascinating, I'm sure you guys have seen some of this on some of the CSI type shows, crime scene investigation things, whether they're true crime or fictionalized, is this idea of being able to take skeletal populations and create facial reconstructions based upon that. Now sometimes they're even using CAT scans of mummies and whatnot. They've done this for Tutankhamun. And so you don't necessarily even need to have the skull by itself and cleaned off, but it's still based upon the same principles. And these were developed by a Russian scholar by the name of Mikhail Gerasimov, and he died in 1970, well before his contribution was recognized broadly outside of Russia. And certainly because this was at the height of the Cold War, there wasn't a whole lot of credit given to scholars by either of the belligerents in that particular conflict during the time. But the techniques that Gerasimov developed have now become standard practice in forensic facial reconstructions. Here you can see an example of how this facial reconstruction works. Basically, you take a mold of the skull and you place these pegs at different spots on the skull to the average tissue depth. You then place the musculature and glands and other ligaments of the skull onto them in the appropriate locations. You then place the skin, glass eyes, hair, eyebrows, and all of that. And what's fascinating is that these reconstructions are accurate enough when used in modern criminal investigations and forensics that relatives of and friends of the individuals in question are actually able to recognize it as a very close likeness of the individual. So when we use this in an archaeological context, it gives us a whole nother layer. We're actually able to get an idea of what people may have looked like in the past, and it's a pretty close resemblance to them. Here's one of the reconstructions done by Gerasimov himself of Ivan the Terrible. This does illustrate one of the things that has to be recognized about the subjective artistic component to facial reconstructions, is that not saying that Ivan the Terrible was a teddy bear of a guy or anything, but given that Gerasimov was working under the government of the Soviet Union at the time, there was not a whole lot of incentive for him to present a neutral reconstruction of one of the tsars of Imperial Russia. And so there can be sometimes some choices that the artist makes that can change certain aspects of the visage and facial expressions and whatnot. Though the success rate in criminal investigations suggests that even if Ivan looks rather unhappy in this particular reconstruction, it's probably a fairly close likeness of the individual. Other things that people are able to look at from archaeological studies of human remains are things like paleopathology. Wounds and disease, for example. On the left there, you can see a skull fracture to the frontal bone. The one there in the middle is a projectile point, an arrow point wound to a rib. And on the right there, you can see the damage done to a spinal column by tuberculosis. One particularly interesting set of things are evidence for malnutrition, and being able to look at that in the past and over long periods of time. Parodic hyperostosis and cribra orbitalia, shown here, top and bottom respectively, are conditions that are linked to anemia, low protein diets, and high levels of infectious disease and parasite loads. One interesting place that you do see an increase in the archaeological visibility of these two pathologies is with the adoption of agriculture and sedentary village life. It's fascinating, especially given our expectations, that in fact the early farming communities, and for many millennia in farming communities, people were not anywhere near as healthy as they were when they were hunters and gatherers. The difference is that there are far more farmers than there are hunter-gatherers, because agriculture is able to create conditions for population growth and can sustain larger populations. The problem is that those individuals living within those societies are not as healthy on an individual basis. So individual health, individual freedoms, much higher for hunter-gatherers than for agriculturalists, and we're able to see the evidence for that in these skeletal populations. Another example of characteristics in skeletal populations that are visible archaeologically is that of enamel hypoplasias. And you can see these lines here on these teeth, and they're indicative of episodes of severe malnutrition. And the interesting thing is, because they're in the teeth, they represent a permanent record of that individual's health as a child, because the enamel on your teeth is forming when you're young. And if you have episodes of severe malnutrition or illness, you can develop these lines, these hypoplasias in the enamel of your teeth. And no matter how long you live, whether you get healthy, whether you become well-fed and never undergo another episode of malnutrition after that, these remain locked in the record of the teeth. And so they present a different kind of ability to look at this. Here I want to sort of give you an example of a single individual, a life history approach, if you will, looking at this bioarchaeologically. The individual we're going to talk about is Kinich the founder of the royal dynasty of the Maya city of Copan, Honduras. And I want to draw your attention to this particular feature right here. It's his right arm, and there's this shield that's strapped to his right forearm. One thing that you can say is that Kinich was one seriously tough dude. His skull, shown there on the right, had at least 2 skull fractures from blows to the head that he received. Both of those skull fractures, however, healed many, many years prior to his death. This is the upper dentition of Yashkukmo. You can see the teeth, the 4 top incisors and adjacent canines have been drilled and inlaid with jade. And then some of these teeth have also been carved and notched. This is all without modern anesthetic. So you can imagine the experience of having this decorative dental work done in the first place had to have been excruciatingly painful. And hopefully the signaling of incredibly high status that this first king of Copan was going for, hopefully that was communicated effectively. This is his right arm, his right lower arm, his ulna and radius. And you can see the ulna, the one that goes from the point of your elbow to the side of your hand that has the pinky, is on the bottom there. And the radius, the one that goes from the side of your hand with the thumb to the inside of your elbow. is there at the top. The radius, you can see, was a break, and it healed but bent. The ulna, however, never properly healed back together and created a false joint, so that every time he moved his forearm, those two ends of bone would have ground together and been unbelievably painful. Remember that sculpture? Right here. Maybe one of the ways that you can avoid having that pseudoarthrosis move is by strapping a stiff and rigid object to it, right? Almost like a splint. And being a warrior king, maybe strapping a shield onto your arm is the best way to project power and strength rather than injury. You can see here he suffered massive arthritis and damage to his left shoulder. And this is the proximal left humerus and scapula fragments you can see there. Given his significantly damaged right arm, you can imagine that the left arm would have taken up some of the slack there, and so got a whole lot of use. Here you can see his sternum, which, because of a blow to the chest, at some point, many years before his death, the ribs and sternum actually separated from one another. And so he would have had a flail chest, what's called a flail chest, and a Darth Vader breathing pattern would have resulted from that. This warrior king of Copan suffered all of these injuries years prior to his death, and yet continued in the role of the leader of his people. You can also look at things like medical practices. You can see there, top of the screen, there's an example of trephination, where this is a Peruvian example from 1500 years ago. And this is something that was done if someone suffered trauma to the head, a concussion, a blow to the head. One of the things that would often result in death isn't the initial blow itself, but is the swelling inside the constraints of the skull. And that swelling is what causes the brain damage, bleeding on the brain, fluid in the brain. All of these things can result in death themselves, rather than just the initial blow itself. It's the body's reaction to that. And so one of the ways you can relieve pressure inside the skull is by opening it up. This is an incredibly dangerous procedure, and the risk of infection is extreme. But this example that we show here, this person actually survived this trephination in ancient Peru. Other examples you see here on the right. Examples of amputation and prosthetics in the past. The one on the top right is an Egyptian example from a foreman working on construction in Egypt. Obviously, a place you could imagine it would be not too difficult to lose a toe. But they constructed a prosthetic device for that individual, and they continued living their lives, and was even buried with the prosthetic on. You can see here in the bottom right is an example from 5th century BC, Germany. And this individual had a prosthetic foot on their left leg. So you can actually look at these ways in which people have both survived severe trauma and then compensated for it in different ways, both technological and biological. And there in the middle you see an example of cranial modification. This is something that you see in a number of different parts of the world, where different people, often to signal aspects of identity, either related to ethnicity or class, status, whatnot, would practice modification of skulls in infants, either with a cradle board or binding of the head, to result in a shape of the head that they found to be either more pleasing or signaling of a particular status. No, the ancient aliens people don't know what they're talking about. These are not human-alien hybrids of any kind. And in fact, unless you think this is a particularly bizarre practice, here in Southern California, I have seen kids wearing these foam helmets that parents have placed on them to give their heads the proper shape. Part of this is related to modern practices of keeping kids laying on their backs, and so it results in flattening of the back of the head and a little bit wider portion in the back of the head these days than before. And some people don't feel that that is the correct head shape for their child, and so they will actually have them wear headgear so that their heads will achieve what they deem to be the proper shape. Given what we know about human diversity around the world, deciding what the correct shape is a pretty subjective matter rather than an objective one. And so this cranial modification that is practiced in a number of different times and places around the world is along those same lines. It's achieving either an aesthetic or status marker shape. Also very important for understanding the past is looking at burial practices. And burial practices don't just tell you about the individual in ways that we've talked about with regard to paleopathology and diet and health and whatnot, but they tell you about the society that practices these rites, these rituals of internment or cremation or whatnot. And so the relationship that societies have with the bodies of the deceased is an incredibly important area of investigation. One area that I'm going to talk about that's kind of interesting is the area around La Paz in southern Baja California. This is the Bay of Balandra here, and it's a semi-arid to arid landscape, but close enough to the tropics that you get a different kind of vegetation community and adaptations of these folks in southern Baja California than you see in the part of the peninsula closer to Alta California. At the site of El Conchalito, near La Paz, they have a whole burial tradition where individuals were sectioned with the flesh still on the different body parts. You can see the different sides of this individual's rib cage, their spinal column, the two femurs. And this is not a collection of dry bones that was reburied in a secondary burial. These are primary inhumations, primary burials, but where the individual's body was cut into a number of different sections before being placed here. And this is not the disposal of, a victim of some crime or whatnot. These are in cemeteries. There's grave goods placed with them. There's even grave markers of mounds of shell on top of a number of these individuals. So these were very much graves, very much tombs. And it is probably related to the native Baja Californians' attitudes towards the dead and ghosts and other traditions that they have surrounding the importance of the dead remaining dead and not returning from the grave. If you look at a lot of the cosmologies for the First Nations of the Baja California Peninsula, they were predisposed to find the concept of zombies to be absolutely horrifying. This was a concern of theirs, right? Not that zombies actually existed, but that people once dead needed to remain dead. And one of the ways you can ensure that is by sectioning the individuals into various pieces, and that pretty much guarantees they're not going to get up and walk around again. Sometimes, though, rather than achieving a permanent departure from this life and this realm, some societies are trying to preserve the presence of these individuals. Not just in ancient Egypt with mummification for the afterlife, but some societies actually attempt to preserve the presence of the ancestors in this world, not just in the next world, but in this world. One example of that are the Chinchorro mummies of Chile in South America. And these mummies date as far back as 5,000 BC, so over 7,000 years ago, some of these. And what you had here was upon death, the people, would take their relative and they would remove the skin. The organs and muscles would be removed from the bones. The body would then be filled with clay and vegetable fibers, and then a mask and the person's natural hair. Sometimes the mask was made of skin, sometimes it was made of clay, but the person's own hair was placed back on this mummy. And these mummies would then be placed on these hillside cemeteries overlooking the sea. And the Chinchorro people were people of the ocean. They were fishermen along the coast of ancient South America. And so these ancestors, preserved in this way, would be looking over the activities of their descendants. And so you're actually, instead of trying to achieve a permanent break and departure of a person's essence from this realm, in the case of the Chinchorro, you're trying to do the opposite. You're trying to hold on, give them an anchor in this world, even though their body may be, their life has ended in a biological sense, but you're trying to create a permanent housing for some aspect of their spirit. Given that these examples are many thousands of years old, and we don't have a complete written description of what the specifics of the Chinchorro belief system was, but we can look at it from a structural way and understand that it's very different from the Baja California example. In fact, it's the opposite end of the spectrum in some ways from that. In terms of thinking about messaging and symbols, one example that I can give is that of the Athenian cremations. This is a sculpture of Pericles of Athens. And during the Peloponnesian War, Athens and Sparta were fighting a long, protracted battle for control over the Greek peninsula. And the Athenians, when they had suffered one particular defeat by the Spartans and had a number of their large number of casualties, Pericles decided that rather than have all of these dead warriors buried separately, as was the standard tradition, they would be cremated, and then all of their remains would be placed together in a common tomb. This then would symbolize the fact that the honored dead were together in repose in Athens, that they were being celebrated for their sacrifice to the city and nation of Athens, but they were all together in death. And so the political message there is that, well, they're together in death, we should be together in life. And it was an attempt to encourage greater unity in the case of this conflict during that time. So the messaging can even be political. It's not just about the specifics of cosmological or religious belief, but it can also be political. Another example that I'll talk about that shows some ways in which we're able to understand people in the past by an examination of human remains. I'll draw a few examples from the ancient Mexican metropolis of Teotihuacan. Here you can see in the center, that's actually the Pyramid of the Sun at Teotihuacan. Bottom left is a picture of the facade at the Feathered Serpent Pyramid. And on the right, you see two images of some of the remains recovered from underneath the Feathered Serpent Pyramid at Teotihuacan. In contrast to the terracotta army at the tomb of the first emperor in China, at Teotihuacan, upon dedicating the construction of the Feathered Serpent Pyramid, one expansion, they placed actual warriors as the dedication to that construction. And what's interesting is that by conducting both studies of isotopes and other measurements of these individuals and DNA and isotopes, they've determined that these members of the Teotihuacan military were not all from Teotihuacan originally. They were not all born in the city. Some of them were born in West Mexico, in East Mexico, even some from as far south as Oaxaca. So this is fascinating because it tells us that within Teotihuacano society, it was apparently not necessary to be born in the city to be a high-ranking member of the military. And that's fascinating, especially for an ancient metropolis like this to have that kind of an open membership in such an important component to the structure of the state. Also, these other oxygen isotope studies and strontium and whatnot that have been done have demonstrated the presence of both multi-ethnic and regional ethnic neighborhoods. You can see on the west side of Teotihuacan, you see both a barrio, a neighborhood of people from Oaxaca, another one that was made up of people from Michoacan. And then on the east side of the city, you had what's called the Merchants Barrio, which was comprised largely of people from to the east from the state of Veracruz along the Gulf of Mexico coast. And so this demonstrates that Teotihuacan society was not mono-ethnic, and it wasn't even just people from one region of Mesoamerica, but people were living in this city, coming from all different parts of Mesoamerica, and interacting with each other in ways that are not so dissimilar to the ways that we interact here in our city of Los Angeles. You have different neighborhoods, you have different people, and it would have been a very rich and diverse cultural life in this ancient city. Earlier in class, we've talked about certain aspects of the use of genetics, as we've talked about with mitochondria having its own genetic code separate from that of the nucleus of the cells. One of the things that we're able to do with both contemporary populations as well as archaeological ones, ancient DNA, is we're able to look at patterns of, for example, here in this one, colonization of the New World, migration from different parts of the Old World into the Americas. And this can help us to understand a whole number of evaluate a number of the different models for how people first arrived in the Americas, what routes they used, what regions they came from initially, and have a much more clear understanding of the process beyond just the sites on this end, but also hopefully help us to reconstruct the original homelands. Finally, one thing that I want to talk about is the fact that a lot of these studies have a reciprocal relationship with forensic anthropology, which is not just about archaeological examples, but can deal with a whole range of things from crime scene investigation to obtaining evidence for genocides that get used at the World Court for prosecuting war criminals. It is a very empirical study because this is an effort to collect evidence that's used in criminal cases, not just in archaeological publications. One place that does a lot of this study is the University of Tennessee at Knoxville has the Forensic Anthropology Center, is its formal name. One of the entities that the Forensic Anthropology Center administers is the Body Farm. And the Body Farm is a place where bodies donated to science are used to obtain the empirical research on things like decay, evidence preservation or loss, Forensic entomology, that's the part with the flies and maggots and whatnot, how you can tell how long a body has been there based upon that examination. Soil chemistry, how does the fact that a body has been here change the chemistry of the soil? What are the different ways to detect human remains? Research on the development of things like gas probes and the training of cadaver dogs, which are useful not just in criminal investigations, but sometimes in disaster recovery situations. A lot of other critical topics in forensic investigation. You need to have places like this where you obtain that. It's not just that somebody puts their fingers to their temple and tries to commune with the dead to figure out how long the body has been there. It's based upon long years of research conducted at places like the University of Tennessee. And on their website, which I have the link to posted down there, so if you're interested, definitely recommend the website. If these are things that are more troubling to you, then don't. But it's a really well done website that has a lot of information and some cool videos explaining how they do this stuff and why and who their different partners are. Really recommend that. But also they just celebrated 20 years of training. The FBI evidence recovery team actually gets their training for human remains at this location. So this is one of the most important locations in the entire country for this research, and it's a place where anthropologists play a major role. And so these techniques that we've been talking about, examples of from archaeology, are ones that are developed in a very rigorous context. And so this is one of the areas where the data that's generated from studies of human remains is some of the most well-founded in the field of archaeology. I hope this has been interesting for you guys. I hope you've learned a thing or two, and I look forward to our next lecture. Have a wonderful day.